Let's walk through a relatively complicated probability problem, and this involves multiplying probabilities. It says Lizzie has 7 Harry Potter books, 3 are paperback and 4 are hardcover, and she randomly chooses 4 books to take to school with her. What's the probability she selects 2 paperback and 2 hardcovers? Well, let's take a look and see how we begin. When starting probability problems, usually the easiest thing or the best thing to do first is to figure out the total number of way outcomes that can occur, and then we do the bits and pieces on top second. Usually this number on bottom is easiest, I think. So the other question is we want to this involves some calculations, and you need to think about whether you're going to use permutations or combinations or something else entirely, maybe just fundamental counting principle. Or maybe if you draw out a diagram or a table, you can see intuitively by looking at that table what you need to multiply together. In this case, we're going to use either permutations or combinations. So take a look and think for a minute what you think would be appropriate here. All right. I'm hoping that you had a minute to think about this. Now, I'm going to give you what I think. What I think is because of this keyword chooses, I'm more likely to go with combinations than permutations. Usually for permutations we see something like order or arrange. Usually for combinations we see something like choose or select, or with cards we see the word draw. And so in this case we're going to go with combinations. So I'm going to go ahead and get rid of that. And let's go ahead and see how we're going to do this. We'll do the denominator first. There's 7 books. She chooses 4. So we're going to do C. Let's do one that shows up a little bit better. We will do C, 7, comma, 4. And so that'll be the total number of ways she could choose 4 books from the 7. The only thing is, she's not choosing just any 4 old books. We want to know what the probability is that she selects 2 paperback and 2 hardcovers. So the way that we approach that is we first say, well, there's 3 paperbacks and she chooses 2. So C, 3, comma 2. And then the next thing is there's 4 hardcovers and she chooses 2 of those. So we do C, 4, comma 2. And then the last thing is, what do we do with those guys? And I'll tell you what the deal is that because we are multiplying, well, because we're saying how many ways can we do this and how many ways can we do that, the key word here is and. And when we're trying to find out how many ways we can do this and that, we tend to multiply. So let's go ahead and actually show that that is what we will do. We'll multiply these together. Now, the last thing I'd like to share with you is how we can do this quickly and easily using the calculator. So far, when we do C's, we've had to do some fancy formula that involve factorials. Okay. And I really want you to know that formula. It'll be useful for a number of reasons, but for one thing, it'd be nice to know that you could double check, what the result is. But if we want to do a lot of these, the calculator does all this for us. So I'm going to show you how to do that. So I'm going to show you guys with this guy. Let's go ahead and turn it on and clear it off if I can. There we go. Let's clear this off. So I'm going to show you guys how to use this calculator. This is a graphing calculator. It's the TI-83. And it has this stuff built in. Now, other calculators have this as well, and in class we can figure out how to use them. But on this guy, if I go to Math, and then I go to the PRB or probability menu, I can see NPR, NCR, and factorial. And those are the types of things that we're going to use here. Mainly we're going to use C though. We're going to use the NCR. Now, in other math classes, when you have this C, N, comma, R thing, you might see something, and it might be written like this instead, and this is how it's written in the graphing calculator, NCR, instead of CN, comma, R. And also, in some math courses, they actually do this. it's written out like this. It still means the same as all of those, but this is called the choose function. And that's one reason why choose is one of our keywords that we're going to use combinations. So let's go ahead and let's use the calculator. So we're going to do C3 comma 2. So on many calculators you'll enter the 3 first, and then you'll go ahead and find your NCR function, and then you'll enter it, and then we'll go ahead and put the 2 in second, and then finally we'll hit enter. And in this case we believe that the outcome there should be just 3. So at this point we're kind of going on faith. So let's try another let's try the rest of it and see what we get. So C4 comma 2 is next. So we'll do 4 and then math, and then go over to PRB and down to NCR, and then 2. And that gets us 6. And so we'll go ahead and we'll do times 6. And then finally 7 NCR4. Let's go ahead and do that. And so we go 7 math, NCR 4. That gets us 35. So we'll go ahead and we'll write that here. And in the end, that gets us 18 over 35. And if we could reduce that fraction, we would, but we can't. So that could be our answer. Also, I do, many times in probability, we'll express our answer as a percent. So let's see what that is. 18 divided by 35. That equals 0.514. I'm going to round to just that. And then we'll convert that to a percent of 51.4%. So again, this is 0.514. And we could rewrite that as 51.4%. And that is the answer to our question. When we ask what is the probability that she selects 2 paperback and 2 hardcovers, it's about 18 out of 35, or 51.4%. Remember, when you're doing probability problems, the answer is always going to be a number between 0 and 1. It could be 0 or it could be 1. And that's because those represent 0% all the way up to 100%. And that's what probability numbers tend to look like. They're fractions. If we're asked the question, how many ways can you do something, that is where we will not expect to get a fraction. That would be a whole number instead. Okay, I'm going to stop right here.